All right, everybody, let's go ahead and get started with our Algebra 2 final exam review, Category 3. Category 3 is going to be going over writing and solving systems of equations and inequalities. So let's go ahead and get started. Just a review. You are going to have 40 questions that need to be done in 2 hours. So again, this prep is to kind of speed up our process of work here. You're going to see here that we're going to be dealing with a lot of systems of equations. So we're dealing with multivariable systems. 2 and 3, and then we will also be dealing with systems of inequalities, which follow a lot of the same systems and rules. This will be very Desmos heavy, as remember this is a timed exam, so while all the questions that we will go over can primarily be done by hand, it is highly recommended that they're done using Desmos, as you on average only have about 2 to 3 minutes a question, so you want to be really quick on these. So let's go ahead and get started. So this first question says, what is the solution set for 2x minus 1 times x plus 3 is greater than or equal to 0? So we could break this down into separate parts. We could find each little bit there and test plus or minus symbols to see how we're doing. I'm going to be honest with you. This is a time test. We don't have the time to go through that process. We want to get these answers nice and quick. So I put this one here into Desmos. You'll see my Desmos work there. I highly recommend that you guys put the same thing into Desmos, see if you get the same thing that I do. But what we'll see here is that this is going to go forever to the left, so negative infinity, and this part is going to go forever to the right, to infinity. So when we look at our notations here, we know we're going from negative infinity. Now, infinity and negative infinity is always going to be bounded by parentheses because we can never reach there. And then it stops here, and I clicked on these points at negative 3. So already seeing this, negative infinity to negative 3, I can already eliminate C and D. We're good with that, right? We already know that's that right. Now the difference between A and B is parentheses and brackets. So parentheses, okay, this is for when it does not include. That would be something like holes, right? Or dash lines. Brackets are included points, and that would be for points and when we see like solid lines. So this negative 3 has to be a bracket, and we see here at 0.5, or like we have in the answer choices, 1/2, that 1/2 is also included. I know it's included because I have a solid line, and I also have this equal sign in the question, right? So that would be a bracket, and this is going to go on to infinity, parentheses. So that means that our answer choice here has to be B. Okay. Again, I recommend put this into Desmos, see if you get the same thing. Try clicking on those x-intercept points so you get those exact points. Give it a shot. You can also, and you will have to tell me the solution set for this question here. So you will put this into Desmos. Be very careful with your brackets and parentheses. Okay. If you have any questions, let me know. Let's go ahead and move on to the next one. So what is the solution set for the system given below? So for the system given below, what we're going to have here is we have a system of equations x plus y equals 4 and x squared plus y equals 2. So we could do this by hand. We could do this using substitution, like x plus y equals 4 and x squared plus y equals 2. And what we could do is we could set both of these equations equal to y. So we'd have y equals 4 minus x and y equals 2 minus x squared. And then we could set these two equations then equal to each other. 4 minus x equals 2 minus x squared. And then we can then isolate our x values, so we can add x to both sides, right? And then subtract 4 from both sides. So we get 0 equals negative 2 plus x minus x squared. Okay, and then what I'm going to do is I'm going to kick everything to the other side. X squared minus x plus 2 equals 0. That way I can try breaking this down to 2 parentheses. But I want two values multiplied that give us x, and then added or subtracted that give us negative 1, but multiplied give us 2. So factors of 2 would be plus or minus 2 and plus or minus 1, right? And so in order for this to be true, they both have to be 2 positive or they both have to be negative. And this doesn't work. This is no good. This is no good. This is no good. What I recommend here, guys, is don't do all this work. If you can, that's awesome. That's amazing. Give it a shot. But we can see here on the problem, when I graph it, the solutions need to be where these two lines would intersect, and they don't intersect. They don't intersect at all. So because they don't intersect, that means that we have no solutions. If they did intersect, that's where your solutions would be. So graph this, see if I'm correct on this. I mean, I should be, and then check this answer. Go ahead and do the same thing for these two equations. Is there a solution? If so, there should be 1, 2, or no solutions at all in this. Graph it and see where those two graphs intersect. Okay. All right, so the next one here says the theater sells 3 types of tickets: general admission, senior citizen, and child. Mark bought 9 general admission, 2 senior citizen, and 3 child tickets and paid $170. Sarah bought 5 general admission, 4 senior citizen, and 7 child tickets for $173. And Kyle bought 4 general admission, 1 senior citizen, and 6 child tickets for $116.50. Find the cost of each type of ticket. So what I do when I did this one, guys, let me break down my logic here. For the senior citizen, or general, we're going to say general, I tag that as my X value. My senior citizen, I'm going to say is Y, and my child is Z. So I had to come up with my 3 equations given this information. So Mark bought 9x, 2y, and 3z. 9x plus 2y plus 3z equals, and he paid $170. Sarah bought 5x plus 4y plus 7z. So we'll set that up as 5x plus 4y plus 7z equals 173. And Kyle bought 4x plus 1y plus 6z. So 4x plus 1y plus 6z equals 116.50. So this is our 3 variable system of equations, and we got to solve for x, y, and z. Now this can, I'm going to tell this right now, this can be done by hand. You're going to use elimination method to eliminate a variable. You're then going to plug into that system, solve for the other variable, then plug into the, it's a lot of work. Again, you only have 2 or 3 minutes per problem. So once you have your equations, plug it into Desmos. And so what you're going to see here is what I've done is I've plugged this into Desmos. Okay. But when we do this, you're going to see that it already starts off with a y value, I'm sorry, a z value of 1. So it's already saying like, oh, if z is 1, this is what the graphs look like. So we need to find when all these intersect. So what you'll do is you're going to play with this drag bar here, and you're going to move it around, and you want to make sure that all 3 points intersect. When they all intersect, that is where your solution is. So I had to mess around, and when I saw that z was like close to 8 and 9, so between 8 and 9, I got really close there. So that I tried 8.5, and it boom, it worked exactly at 8.5. Okay, so it worked exactly at 8.5. So that means that my z value here was 8.5 equals 8.5. So that means that the child tickets are $8.50. And then at that point, well, this is where we would get our x and our y value, right? This is our point. That means that x is $13.50. So that means that the general admission tickets are $13.50, and our y value was $11.50, which means that our senior citizen tickets are $11.50. So Desmos does all the hard work for it, but we got to make sure that we come up with the correct equations, plug them in correctly, and we got to make sure that we use this right drag bar here to get that right z value. So you want to make sure that it is there. at that 8.5. I highly recommend, guys, put this one in Desmos, get a little bit of practice, try getting at that 8.5. What you can do too is you can actually type in 8.5 and you'll see that it intersects there. But play with the bar, see how the lines move, get a feel for it before you move on to the next problem. So here on this problem, I do want you guys to come up with your equations. It says here Mason has a collection of 49-cent stamps, 20-cent stamps, and 3-cent stamps worth $23.55. He has 56 49-cent stamps and 20-cent stamps, and the number of 3-cent stamps is 9 more than the number of 20-cent stamps. How many of each does he have? Okay, so let me help you a little bit with this. So he has, and we're already going to start labeling these. He has 49-cent stamps, which are X, 20-cent stamps, which will be our Y, and 3-cent stamps, which is our Z. Okay, so our first equation would be if he has 0.49x plus 0.20y plus 0.03z, this has to equal 23.55. This is our first equation. I am helping you guys out with this because this is a little bit of a wordy thing. It says he has 56 total 49-cent stamps and 20-cent stamps, and the number of 3-cent stamps. Okay, so he has a total of 49-cent stamps and 20-cent stamps. So that means that so much X plus so much of Y has to equal 56. So this is another equation. But now, because it is a 3-variable system, we have to have another one. It says the number of 3-cent stamps is 9 more than the number of 20-cent stamps. So we get our 20-cent stamps, which is Y, plus 9 more equals our number of 3-cent stamps, which is Z. Okay? So we have our 3 equations. We can use these 3 equations to solve for our X, solve for our Y, and solve for our Z. I'm going to let you guys do that one. If you have any questions, please, please, please message me on Teams, guys. I'll be more than happy to help you out. Alright, so now when we're looking at this problem here, it says according to a cookbook, meat should always be defrosted in a refrigerator in its original packaging. 6 hours should be allowed for each pound of meat to be defrosted, less for thinner cuts. The system of linear inequalities given below represents the solution region of proper defrosting conditions. So t is greater than 0, so time has to be greater than 0. P has to be greater than 0, so the pounds has to be greater than 0. And t is less than or equal to 6p. It says if the defrosting time in hours t depends. So they're saying, and this is like the real skill here. It says t depends. So that means if it's the dependent variable, that means that t has to be our y. So in other words, y is greater than or equal to 0. And then that p is our independent, so that means that p is our x, and that's going to be greater than 0. So if t is y and p is x, then we need to have this t here would be y is less than or equal to 6x. And so what I did is, once I had these inequalities, I put these into Desmos. These equations match these here. Cool. So really now all we have to do is see which one of these points is true. So here's my x and my y. So 2.8 would be somewhere here, and 12, way up here, maybe is not a solution, maybe. Okay, 2.8 and 12 is a solution, maybe. Okay, 12 and 2.8, so 12 and 2.8 here. Oh yeah, it's pretty close, right? Pretty close. And the last one is not. Okay, so it's asking us what are the coordinates of the roast. So the issue is here is, man, like we're getting something that could be true, right? Like what's going on here? So we got to be very careful with our x and our y. Okay, our x value is pounds, right? This is our p, and they're talking about 2.8. So that means that these guys, we can't have x as being 12. These are the y values. So C and D are no good. So then it comes back down to this situation. So these points don't help over here. So it's like, okay, is this point up here, okay, is this 2.8, 12 a point? So I didn't zoom out enough on my graph, and I did this on purpose because I also wanted to like show you guys mathematically how this works. Okay, so what we can do is we can take this x and y, and we're going to test out this last statement. If I said y is greater than or equal to 6x, and I plug in 12 is less than or equal to 6 times 2.8, okay, so I gotta have this here. We then get 12 is less than or equal to, if we were to do this, and let's do it by hand here, we're going to multiply it by 6. I think it's always good to try this out. 8 times 6 is 48. 6 times 2 is 12, plus 4 is 16. So we get 16.8. And this is a true statement. So because this is a true statement, we know that this is true. What I recommend you guys do too is put these equations into Desmos and see that that 2.812 is going to be within the solution. Okay, it will be in the solution, I promise. Okay, if you have any questions, message me on Teams. Let's go ahead and move on to the next one. And so here I want you guys to graph the system of linear inequalities, then choose the point that represents the solution. So put this into Desmos, graph it here, and then which one of these points falls into that solution set. I think you guys can do that. Let's go ahead and move on. So here it says, what is the solution set for the inequality given below? So here we had an absolute value inequality. This is very, very much aligned to one of the problems we did earlier today. When you look at this here, we see that this is going to negative infinity. And here we have these dashed lines at 1/2. It's dashed, which means we would never get there. So that would be parentheses, parentheses here, and would be here at 4.5, which would be 9 halves, parentheses because it's dashed, and that goes on to infinity. So this would be our answer here. So looking at this, we have negative, and this should be a negative 1/2. I apologize for that mistake there. So negative infinity to negative 1/2. So we already know that B and C are no good. And then we would go from 9 halves to infinity. So our answer choice here is A. Again, we could use the KISS method for this and solve this. We don't have time, guys. That's gonna take about 5 minutes to do for some of us when you want to be answering these in 2 to 3 minutes. So plug it into Desmos, look at the graphs, but you gotta be able to know how to read these. So if you see these little dashed lines, that means you're gonna be using parentheses. If you saw solid lines, you know that would be brackets, and we covered this in an earlier slide. So this is your problem here. I want you guys to give me the solution set using the proper notation for this absolute value inequality. Okay, give it a shot, plug it into Desmos, use the proper notations. That's what I'm looking for. Let's move on. So this one here says, which region in the graph below is the solution set for this, this system here of 3x plus y is less than or equal to 14, and x minus 2y is less than or equal to 8. And so what you want to do is you want to look at the double shaded regions. Now this one is super tricky. The way that these hash marks are coming out here, what it looks like is like B is supposed to be the answer. But if you graph it in Desmos, we see here for sure that the double shaded region is this region here. You got, like, don't trust the picture here. This is the issue. Don't trust that picture of B there. Okay, sometimes you get things like that, and it's like, oh, well, that was misrepresented. Yeah, so our answer here has to be the section on the left, and that would be region A. Use Desmos, because that section of B is only representing that first part here. Up here, that only has one shaded. C is single. C has no shade, and then D only has one shade. So it is this area of A. Using those skills, I want you guys to graph this here, and I want you to solve this using your graphing abilities. While this is not directly aligned with the inequalities, I do want you to tell me where is that point of intersection. So where do the lines intersect? Okay, let's go ahead and move on. So this is a 3-variable system. Oh man, this one is pretty crazy. You definitely do not want to do this one by hand, just looking at those fractions, and we'd have to multiply everything by 5 on that second equation. No. You plug this into Desmos like I did there. Okay, you plug that into Desmos, and this one gets a little tricky when having to move that z bar around. Okay. Again, we have to see where all the lines intersect. When this happens, we get that z equals this 0.888888, and it goes on forever. When we do this, well, we know that we get our x and our y values. And so I got a y value of 0.4583. And so what I did here is I wanted to see, well, that did give me a fraction, and I kept putting that in. It wasn't exact. So what I did is I tried all of these answer choices here, and negative 11 over 24, well, this was equal to negative 0.458, and because it's negative, well, that was no good. This guy here, 11 over 24, is equal to 0.45833, and goes on forever, and this is it. Like, this is our answer here. This is what matched. So I used Desmos to solve the system. It got a little crazy with that z value, but then you want to try the answer choices too. Okay. Use Desmos, guys. Such a good resource. Let's go ahead and move on to the next one. So I want you to solve this system of inequations using Desmos. You're going to plug in 3x minus 5y plus 2z equals negative 53. Your next line would be x minus 7y minus 4z equals negative 37. And then you'd have 5x plus 9y plus 2z equals 57. You're not going to get crazy situations like the one that I just did. You're going to get nice rounder answers for this. Okay, but use Desmos for this. Make sure that you use that correct drag bar for z there, and you'll get all your values. Let's go ahead and move on. And so for this last one here, this is a system of inequality questions. So it says a manufacturer produces 2 types of barbecue grills, Old Smoky and Blaze Away. Production of these grills requires the use of 2 machines, A and B. So they both, to make these guys, they have to go through the 2 processes here, is what that's saying. The number of hours needed on both machines are indicated below. Okay. It says which machine can be used each machine can be used 24 hours a day for a profits of $4 on Old Smoky and $6 on Blaze Away. Let X represent the number of units of Old Smoky models made a day, and Y represent the number of units Blaze Away made per day. If a system of linear inequalities is formed to determine the number of each type of grill that should be produced to maximize profits, which of the following is not an inequality in the system? So what I did is I actually graphed all of these here. And what happens is when we have situations like this, your parameter should always be x is greater than or equal to y. I'm sorry, not equal to y, equal to 0. which means that we need to have positive values for x. And we also need to have y is greater than or equal to 0. We want profits, right? So we're going to be in the positive here. Knowing this x greater than 0 has to be in the system. So it's asking for which ones are not. Well, this one has to be, so we got to cross them out. He has to be in the system. So then we got to create our own equations here. This is our x, and this is our y. So we know that they're allowed to be on the machines for so long. So we would really say that 2x plus 2y, oops, not 2y, I'm going to confuse you guys, plus 4y, and like they say here, has to be on the machine for at least 24 hours, right? So it can be used 24 hours. So it can be less than, but it can't be more than. So it can be less than or equal to 24. For blaze away, well, that would be the other way. It would be 4x plus 2y is less than or equal to 24. So these two equations make up this scenario here. So because this one is true and this one is true, we can cross these two out. So the 4x plus 6y, why is this one not true? And this is the trap here. They give us this extra information of the $4 and the $6. Okay, and obviously profits have to be greater than 0. But what happens is if you were to graph this, okay, if you graph this equation, you would actually end up getting this line here, and this line does nothing to help. Okay, this line actually has no business at all in this upper quadrant where our answer is going to be. This guy does not at all help with anything in production quality. This is different for profits. So this guy does not help because he is not even in quadrant 1. Okay? So what I'd like for you guys to do here is I'd like for you all to answer this one where it says to raise money to attend a Boy Scout camp. Alex is selling popcorn. Small bags of popcorn sell for $4 each and large bags sell for $6 each. He needs to earn at least $300 to attend camp. He will also earn a badge if he sells 60 bags total of any combination. So it says here, write a system of inequalities to represent this situation in the graph. So we have a lot of information. Like I said on the last slide, the first thing that we want to identify is that x has to be greater than or equal to 0. Y has to be greater than or equal to 0. Okay. He needs to earn at least $300 to attend camp. Okay. And so our first equation means that if we're going to sell small bags of popcorn, let's make that x, and our large bags would be y, we would say 4x plus 6y. And he has to sell at least $300. So this has to be greater than or equal to 300. Okay. And then the last part here is he has to sell at least 60 bags of any combination to get a badge, right? So that means that x plus y has to be greater than or equal to 60. So these are our equations. I want you to plug these into Desmos. I then want you to graph them, and then I want you to answer part B here. I'm not going to give you any more information here on B. I want you guys to try to figure this out on your own. If you get stuck or you have any questions, please send me a message on Teams, and I'll be more than happy to help you guys out. Alright guys, that concludes the Category 3 review. Take your time on this. Be sure to finish it up though. We'll see you all later. Bye-bye.